This video is about a fourth type of sequence called the Fibonacci type sequence. Now those set of numbers that are written down there are the original Fibonacci sequence, and they're very famous because they are intrinsically linked to nature. If you're interested in learning more about that and the golden ratio and how these numbers are related to nature, then just let me know. I can talk about this for hours. But you don't need to worry about that too much for GCSE. We do need to be able to figure out what the rule is though. So looking at those set of numbers, I'm hoping you've already maybe spotted a pattern of how they're linked. If not, can you think about that now? Where do these numbers come from? I'm hoping you can see that if we do 1 plus 1, we get 2. If we do 1 plus 2, we get 3. 2 plus 3, we get 5. 3 plus 5, we get 8. 5 plus 8, we get 13. And so the next number would be 21, because 8 plus 13 is 21, and so on. Now, because the next number in this sequence always depends on the two previous numbers, it's not possible to write an nth term down very nicely for this. What we have to use is something called a recurrence relationship that I'm going to show you very quickly, but it's not essential for this. The key thing is you understand the idea of getting one number from the previous two. That's what Fibonacci numbers are all about. But if we did want to write down the nth term for this, what we would do is I'm going to explain some notation for a minute. So I'm going to call the first term in this sequence a subscript 1. The next term in this sequence, I'll call it a subscript 2. The third term in this series, in this sequence, will be a3. a4 is the fourth number, a5 is the fifth number, and so on. Then, what I can start to write down is a rule. I can write down that the third number in my sequence is the second number plus the first number. And the fourth number in my sequence is the third number plus the second number. The fifth number in my sequence, the 5, that came from 3 plus 2. The sixth number in the sequence, the 8, that came from doing the 5 plus the 3. And hopefully by writing these down here, you can start to see that they all follow a rule where this number here is 1 less than this, and this number here is 2 less than this. So therefore we can write down what's called a recurrence relationship. And this is the nth term, or the recurrence relationship, the rule for the Fibonacci sequence. We will talk about recurrence relationships more in a bit more detail in a later lesson. They're not essential for now. What is essential for now is you knowing the pattern for Fibonacci type sequences and being able to recognize them. So in this example here, this is a Fibonacci type sequence because we can see that 3 plus 3 is 6, 3 plus 6 is 9, 6 plus 9 is 15. We are asked to work out the 7th term. We have the first 5 numbers. The 6th number would be 9 plus 15 is 24. The 7th number therefore would be 15 plus 24 is 39. So 39 is my answer. Next example. We're told that this is a Fibonacci type sequence. The first number is x, the second number is 2y, the third number therefore will be these two added together, so x plus 2y. I need to find the fifth number. So the fourth number, I've got 1, 2, 3, I've got 3 numbers so far. The fourth number would be these two added together. So it would be x plus 2y plus 2y, which is the same thing as x plus 4y, because the 2y and the 2y, when they're added together, I get 4y. So this is the fourth number in my sequence. The fifth number, therefore, will be these two added together. If I add them together, x plus x is 2x, 2y plus 4y is 6y, and therefore that will be the fifth number in my sequence. So that's part A of the question. Part B says the fifth number in the sequence is actually 22. This is 22. And I'm told that the sixth number is 36. And using this information, I need to find x and y. So I know that this equals 22. Ignore the times 3 for a minute there. This here, my fifth number here, is 22. I'm told the sixth number is 36. So I want to try and write something similar down to this for the sixth number. So let's come back up here. The next number in this sequence would be this one plus this one. The fourth number plus the fifth number would give me the sixth number. Adding these together, I would get x plus 2x is 3x, and 4y plus 6y is 10y. So the next number in this sequence, the sixth number in this sequence, would be 3x plus 10y. And that's equals to 36, I'm told that here. So I've got my fifth number here and I've got my sixth number here. And hopefully this looks familiar to you. These are simultaneous equations. That is where this times 2 and times 3 has come from, because in order to solve these simultaneous equations, I want the coefficients to be the same. So I have decided to make this a 6x and this a 6x, so the x's are the same. If I times the top equation by 3, I get this. If I times the bottom equation by 2, I get this. If I take them away, the 6x take away the 6x is 0. The 2y take away the 18y is the 20y take away the 18y is 2y. 72 take away 66 is 6. 2y is 6, which means that y is 3. I can now take this and substitute it back into the original equation at the top. So if I substitute that in here, I get 2x plus 6 times 3. So 2x plus 18 is 22. Take the 18 away from both sides, and there we go. So that's it. That's a Fibonacci type sequence and how we can solve complex algebra problems using it.